Okay, we are ready for week 10, homework number 1. And the big news is that this is a test week. And what that means is, number 1, there's only 3 homework assignments to give you time to study. So just make sure you manage your time this week and leave plenty for that. So in this first assignment, it's all pretty easy. I think you should be able to, after watching this, just go straight and work right through it. So the first one is just making sure you understand all the notation of an integral and what everything's called. So I'm going to go through that really fast. So this is your lower bound. So it's always the smaller number or the left side of the rectangle that you're making to find the area of your function, which makes this the upper bound. And this is just going to be any function. It can be complicated or not, doesn't matter. But whatever's there, as complex as it might get, is called the integrand. So remember, you're finding an integral of the integrand. So you've got your starting and your ending part. And then this here is just what variable you're going to use. So since that's an x, then your variable of integration would be x. So you've actually got a series of questions where it just asks you to fill those things in. So they give you this and you just have to name what everything is. So that's pretty simple. Okay, next part, they give you already all the information you need and we just have to change it into an integral form. So we go from a limit or a Riemann sum into this integral form. And again, it's not too bad. Okay, so the first one is when they start is as a limit. And so when they give you something like that, then they're basically giving you your starting and ending point. So that should make you very, very happy. This should make you happy, right? And so we're just going to do the integral and they're giving you that lower bound and they're giving you that upper bound. So you don't have to do any math to figure that out. And then every time you see this xi star, that's just going to turn into an x. So that's just an x and that's just an x. And so basically you just rewrite this function here. So that's going to be cosine of 2x squared plus pi over 2x. And then you might want to put that in parentheses. I'm not sure if they'll require it. I doubt it. And then just don't forget, since the variable's x, to end with dx, because that part does matter. They might put that in. I can't remember. But that's basically it. So just take this and bring it down. And that becomes an x, and then just don't forget all the extra little things that are in there. But that's also pretty simple, pretty straightforward. So they give you this, and you just pull the pieces down that you need and write it as an integral. And the Riemann sum is the one that you have to at least do like a little bit of math. Not much, but a little bit. So remember that what we're basically making here is a rectangle. So we're taking whatever this curve is, and we're finding the area by calculating basically a rectangle that has the same area. And so this number here, that 3, is your a minus b, which is your, actually b minus a, sorry, which is your biggest number, your upper bound minus your lower bound. So we know whatever b minus a is, we're going to get 3, and they give you that a value. So whatever number is here, they've already given you a. So if a equals 3, and whatever b minus that 3 is equals 3, then you should be able to figure out that b would equal 6. So a equals 3, b equals 6. And so now we should be able to write what we need to do. So we've got our lower bound of 3 and our upper bound of 6. And then this whole thing is just your function. And so we're just going to replace that with the letter x. And then the x. There was one that had like this, and then it had like a natural log and then the same thing next to it. So that one was x natural log x, but this piece was the same. So because it was the same, they both just became x, and it was x natural log x. And then this is always your b minus a. This is your a value. So you should be able to kind of figure everything out that you need, but That one is pretty simple. But just remember that whatever this whole function is, that is x. That is just your function, okay? All right, and then you get to something that you've probably done, I don't know, back in like about 8th grade, maybe Algebra 1, and that is just finding the area. And we're not actually using calculus to do this. They want you to just good old-fashioned area. So I'm just gonna kind of review really fast how that would work on this one. This is an absolute value graph, so it does kind of expect that you remember how to graph an absolute value graph. So hopefully you have not forgotten some of those things. And I'm just gonna kind of put some numbers on here, counting by ones. And I'm going from -4, which would be over here, over to 1, 2, 3, 4, 5, 6, 7. And the easiest way to actually do this is just to put in like your vertex point and then just plug these in to figure out where they would be, because that's all you need is those end points. So this would have a vertex point at 2, -3. So 2, -3 vertex point. Then if I plug in -4, -4 minus 2 is -6. Absolute value is 6. Minus 3 is 3. So at -4, I'm up here at 3. And then over here at 7, 7 minus 2 is 5. Absolute value is 5. 5 minus 3 is 2. So at 7, I'm at 2. And then I can just connect those. And hopefully your graph is pretty accurate so that it goes through. If you want to test and make sure that it really goes through at those points, which helps to make sure you're accurate, use either graph paper or just plug in -1 and make sure -1 really gives you 0, which it does, and plug in 5 and make sure 5 really gives you 0, which it does. So this really does hit at -1. And then you've got these triangles. So then using just, I don't know, high school Algebra 1 geometry skills, we're just going to find the area of each of these little triangles. And this is indeed how they want you to do it. They don't want you to use calculus on this. They want you to use actual like formulas. So these are all triangles. So 1/2 times the base, which is 3, times the height, which is 3. And this one is 1/2 times the base, which is 6, times the height, which is 3. And this one is 1/2 times the base, which is 2, times the height, which is 2. And then if we calculate each of those, this one is above, so it's going to be positive. So we're going to have positive 9/2. This one's below, so it's going to be negative or minus. 6 times 3 is 18, divided by 2 is just 9. And this one's above the x-axis, so that's plus or positive. And 1/2 of 4 is just 2. And then if you calculate 9/2 minus 9 plus 2, you would get a net area of -5/2. And the reason why it's negative is because there's more below the x-axis than there is above. So that is how they want you to do that third section. Sometimes they draw the pictures for you, and then sometimes you have to draw them yourself. It's about 50-50, but you really are just using ordinary geometry and Algebra 1 skills to find the area. And that's it for homework number 1 in week number 10. I hope that helps.